Hello guys, I am Vaishali Kikan and we are discussing chemistry. Today we are going to wind up chapter 1, the atomic structure and the periodic table. We are going to discuss a lot of concepts, so we are going to start our discussion with the periodic trends and the Bohr-Rutherford diagram. We have already discussed about the Bohr-Rutherford diagram and we already have discussed some of the periodic trends. In the periodic table, we are making some grouping and we are calling this grouping as a family. Some of the elements which have similar chemical and the physical properties are termed to be in the same family, right? So the elements in the same family will have the similar chemical and the physical properties. We have discussed different type of families in the periodic table in the last class as well. Right, so we have discussed that we have the similar properties, the chemical as well as the physical properties for each one of the family, like the alkali metals, then the hydrogen, group 2, group 17, group 18, right? So let's discuss what are these properties. For the alkali metals, like for the lithium, sodium, potassium, we have the shiny, soft, silvery structure. They are the shiny, soft, silvery metals. They have highly reactivity with the water. They are highly reactive with the water and thus they are stored in the mineral oil, right? Or they can be stored beside the inert gases, right? So now coming to the hydrogen, which is placed in a separate family. Here hydrogen will behave as a non-metal as well as a metal. Hydrogen at the normal temperature will be behaving like a non-metal, at the normal temperature, normal pressure, non-metal. But at a higher temperature and higher pressure, it will be acting like a metal. For example, at the core of Jupiter planet, at the core of it, we have the hydrogen metal. Because at the core of Jupiter planet, we have the high temperature, high pressure, hydrogen will be acting like a metal. Coming to the group 2, group 2 are the alkaline earth metals, right? This is the group 1 for alkali metals. We have the group 1, group 2 is for the alkaline earth metals which have the metallic properties. These are also having the metallic properties like the alkali metals, but they are not as soft and as reactive as alkali metals. This is the difference between the alkali metals and the alkaline earth metal, or the group 1 and the group 2 elements. Coming to the group 17, which are known as the halogens, fluorine, chlorine, bromine, iodine, these are all my halogens. So they exist as the diatomic molecules like Cl2, right? Then we have Br2, Ni2 and all. So they are highly reactive. Coming to the group 18. In the group 18, we have the noble gases. They are all inert. So I have now defined the properties according to the different families. Now relating it with the Bohr-Rutherford diagram. So you can see in the Bohr-Rutherford diagram, if I see all of the alkali metals, so all of the alkali metals will be having the single valence electron. If you see the lithium, sodium, potassium, all of them have the single valence electron. Now coming to the alkaline earth metals. Alkaline earth metals will be having 2 valence electrons. You can see in the diagram all of the alkaline earth metals have 2 valence electrons. All of the halogens, fluorine, chlorine, iodine, bromine have 7 valence electrons, as well as noble gases have 8 valence electron, or they are having full orbit, right? So this is how, with the help of Bohr-Rutherford diagram, we can understand the periodic trend, because we have the similarity in the Bohr-Rutherford diagram. What is the similarity? 1 valence electron, 2 valence electron, 7 valence electron, 8 valence electron. And the valence electrons are highly determining the type of the structure, type of the nature, the type of the properties, physical, chemical properties of the given element. So here, if I have 1 valence electron, its properties are determined with the help of this valence electron. All of the alkali metals have one valence electron, so all of them will be having similar properties. All of the alkaline earth metal have 2 valence electrons, the similar properties, and so on. Now coming to the reactivity. As we move right in a group, what will happen? The reactivity is going to decrease. So it is decreasing as we move right, but then it start increasing after the group 14, right? So first of all, the reactivity is decreasing, right, from group 1 to group 14. If I say the reactivity is decreasing, then it will start increasing and then again it will drop at the noble gas, right? So after group 14 it will start increasing and then it rapidly decreases at the noble gas. Now coming to the Lewis symbol. Lewis symbol, why they are made? Because the Bohr-Rutherford diagram are tedious to draw. We have to draw the various energy levels and thus it becomes very tedious for the higher atomic number atoms, right? So what we do, we make the Lewis symbol, which was developed, introduced by the G.N. Lewis, who was an American chemist, and he gave the shortened symbol for representing the elements. The Lewis symbol will be having the chemical symbols and some dots. So dots represents the valence electrons around the chemical symbols, like so here we have lithium. Lithium is represented as Li and dot over here. Because the lithium will be having only one valence electron, it is represented by one dot. Beryllium will be having two valence electrons, so we have placed one dot at the upside and one dot at the right. Now carbon will be having 4 valence electrons, so it will be having 4 dots around it. Fluorine will be having 7 valence electrons, so it will be represented by 7 dots around it. And neon will be having 8 valence electrons, which is represented by 8 electrons around it, right? Coming to the atomic radius. What is the atomic radius? It is the distance from the nucleus to just beyond the outermost electron. What is the outermost electron? It is the valence electron. So we see where the nucleus is, we see where is the outermost electron, we see the different distance between these two. This is my atomic radius. Now in the diatomic molecule, if you say that I am not having only single atom, if I have a molecule which is having the diatom, 2 atoms like Cl2, right? So then these are the 2 nucleus. We find out the distance between the 2 nucleus and we are going to divide it by 2. So in the diatomic molecule, atomic radius is the distance between the 2 nuclei divided by 2. Now coming to the ionic radius. What is the ionic radius? It is a measurement of the size of an ion. How big the ion is, it is given to me with the help of the ionic radius. Right? Ionic radius is expressed usually in the picometer or pm. So it is the distance from the center of an ion to the outermost electron. So again it's the distance between the center, which is the nucleus, to the outermost electron. But now here we are dealing with the ion instead of atom. So this is the difference between atomic radius and the ionic radius. Coming to the different types of the ionic radius, when we have the positive ions and when we have the negative ions. Positive ions will be having smaller than their original neutral ion. So here if I have this is my neutral ion, the positive ion will be like this, right? In the case of negative ions, we have the ionic radius which is larger than the original neutral ions. So this is the positive ion, this is the neutral ion. So now coming to the negative ion, this is the negative ion and this is the neutral ion. So the negative ion will be having the larger ionic radius as compared to the neutral ion. So this is how we have the variation in the ionic radius as we are adding an electron or removing the electron, if I am making the positive ion or the negative ion. Coming to the ionization energy. Ionization energy is the quantity of energy required to remove one electron from an atom or from even an ion in the gaseous state. Right? How it is measured in the terms of kilojoule per mole, because we are finding out the quantity of energy and this energy is measured in the kilojoule per mole. So if I want to remove one electron from atom or ion, the amount of energy required to remove this electron is the ionization energy. So the general ionization equation can be represented as Xg plus energy gives X positive G plus electron. So the given X in the gaseous form, when it is acted with the energy, it is forming a positive ion X plus G and the electron is released. So if I discuss about the specific example, the lithium in the gaseous form will be provided with the ionization energy which is 520 kilojoule per mole. This 520 kilojoule per mole energy is going to ionize the lithium to form lithium positive ion in the gaseous state plus electron is removed. Coming to the first ionization energy. What is the first ionization energy? It is the energy required to remove most loosely held electron from an atom or an ion. If I take the atom and an ion, if I see which is the most loosely held electron, only one electron I am removing, which is the most loosely electron. This is called my first ionization energy. Second ionization energy is the energy required to remove second most loosely held electron. Similarly, we have third ionization energy, fourth ionization energy, and so on. Now, if I see in the periodic table, down the group, if I see, the ionization energy will decrease. Why ionization energy is going to decrease? The force of attraction between the electron and the nucleus is going to decrease, because the atom are going to become larger and larger. The atomic radius is going to become bigger. As the atomic radius is going to become bigger, the nucleus and the electron will be having lesser force of attraction, and it is very easy to remove this electron which is less attracted by the nucleus, right? So we require lesser energy to remove it. So down the group we have decrease in the ionization energy. Now left to right in the period, ionization energy is increasing. Why it is increasing? Because we have same number of energy levels. Down the group we were having more number of energy levels, and this is the reason the atomic radius was increasing. In the left to right movement, we have same number of energy levels, right? So here if I talk about, let's suppose helium, we have the one energy level, right? If I talk about the movement from the helium to the right hand side, so here you can see we have the same energy level, but we have more number of electrons over here, right? So these more number of electrons, and here also in the nucleus we have more number of protons, so there will be more force of attraction, so which makes this atom smaller, right? So now this atom, which will be having more number of electrons and protons, will be smaller as compared to the atom which is having lesser number of electron as well as proton. So if I move from left to right, ionization energy is increasing because radius over here is decreasing as I am moving from left to right, because pull on the outer electron is increasing. When I am having more number of protons, the more number of protons are pulling the electrons with a greater force, right? And it will be having lesser atomic radius. Now coming to the noble gas, thus if I move towards the noble gas, which will be having 8 or full outer electrons, so then I will be having largest number of outer electrons, and thus I can say least atomic radius, and thus extremely high ionization energy. Coming to the electron affinity, it is the energy change that occurs when electron is added to a neutral atom in the gaseous state. So here again I am taking the atom in the gaseous state. Now I am adding the electron. Again the unit is kilojoule per mole because I am dealing with the energy. What is the first electron affinity? Energy released when atom acquire first electron. Second electron affinity, energy released when the atom acquires second electron. Third electron affinity, energy released when atom acquire third electron, and so on. The general electron affinity equation would be X in gaseous form plus electron. It is acquiring the electron to form X negative ion, and energy is released. So we can take the specific example as well, like chlorine in the gaseous form is taking the electron, the electron is acquired by the chlorine in the gaseous form to form the negative chloride ion, and here we are releasing 349 kilojoule per mole energy. So electron affinity decreases down the group. If I see down the group, electron affinity is going to decrease. Why? Because if I talk about the atomic radius is going to increase, and we will be having lesser force of attraction to the electrons. So when I have more atomic radius, this protons over here is going to attract the electrons with a lesser force. So outer electron here can come and release lesser energy. But here if I have a smaller radius, outer electron can come here with it is attracted with a larger force with the proton, and more energy is released in this case. Now coming to the electron affinity increase across the period. So if I talk about the period, electron affinity is going to increase. Why it is going to increase? Because right in the period, valence electrons are increasing. As I already told you, when the valence electrons are increasing, the atomic radius decreases, the force of attraction between valence electron and nucleus will increase, and thus I will be having lesser atomic radius and more energy is released when new electron is acquired or captured. So I hope you understood all of the things that I have discussed so far. I hope you understood all of them and you are going to meet me soon in the next class. Thank you so much.